Picture this: a starship gliding through the cosmos, not by brute force, but by bending the very fabric of space itself. A vessel that doesn't just travel faster than light, it redefines what travel means. This isn't the stuff of distant dreams or Hollywood blockbusters anymore. It's real. It's happening. Scientists are pushing the boundaries of physics, and the results are so staggering, so mind-blowing, that even the most seasoned theoretical physicists are left speechless. Warp drive, the holy grail of science fiction, is inching closer to reality, and it's not centuries away. It's not even decades away. It could be within our lifetimes. Buckle up, because this is a journey into the heart of a discovery that could rewrite humanity's future, reshape our understanding of the universe, and unlock secrets we've barely dared to dream of. This is the moment where science fiction becomes science fact, and the implications are nothing short of earth-shattering. Let's set the stage. For decades, the idea of faster-than-light travel was a fantasy, confined to the pages of novels and the screens of starships in iconic franchises. The universal speed limit, light speed, seemed unbreakable, a cosmic law etched into the foundation of reality by Einstein's theory of relativity. Nothing with mass could cross that barrier without infinite energy, and for a long time, that was the end of the story. But then, in the 1990s, a bold idea emerged, one so audacious it turned the physics world upside down. A physicist proposed a radical concept. Don't break the speed of light. Bend space itself. Instead of moving a ship through the cosmos, manipulate the cosmos around the ship. Compress space in front of the vessel, expand it behind, and let the ship ride in a bubble of warped space-time. This was the birth of the warp drive concept, a theoretical model that didn't violate Einstein's laws, but danced around them in a way no one had imagined before. It was mathematically sound, elegant, and utterly revolutionary. There was just one catch. It required something called negative energy, a mysterious substance that didn't exist in any lab. For years, the idea was dismissed as a beautiful but impossible dream, a footnote in the annals of theoretical physics. Until now. Fast forward to today, and the impossible is starting to look inevitable. At a cutting-edge research facility, scientists have made a breakthrough that's sending shockwaves through the scientific community. Using the mind-bending principles of quantum field theory, they've demonstrated the potential to create a warp bubble, a real mathematically consistent distortion of space-time. This isn't just a thought experiment anymore. It's not scribbles on a chalkboard or wild speculation. These researchers ran sophisticated simulations, crunching numbers with supercomputers, and the results were astonishing. Under specific conditions, space-time can be manipulated to contract in one direction and expand in another, creating a pocket where a spacecraft could sit, unmoving while the universe shifts around it. This is the warp bubble, the same concept that powered fictional starships, now appearing in peer-reviewed papers and high-stakes experiments. The early results are so promising that even physicists who've spent their careers exploring the edges of possibility are calling this a game-changer. One prominent voice in the field, known for bridging complex science with public imagination, has gone on record saying, "This could be the dawn of a technology that redefines our place in the cosmos." Let's break it down. How does this actually work? At the heart of this breakthrough is quantum field theory, the backbone of modern particle physics. It's a framework that describes how particles and forces interact at the smallest scales, where the rules of reality get weird. One of its strangest predictions is the existence of negative energy. Normally, we think of energy as something positive: heat, motion, light. But in the quantum world, it's possible to dip below zero, to create regions where the energy of the vacuum itself is less than nothing. This isn't science fiction, it's been observed in real experiments. Take the Casimir effect, for example. Place two uncharged metal plates incredibly close together in a vacuum, and quantum fluctuations, the constant buzzing of particles popping in and out of existence, create a measurable negative energy field between them. It's tiny, almost negligible, but it's real. And now scientists are asking the million-dollar question: can we harness this negative energy, scale it up, and use it to stabilize a warp bubble large enough for a spacecraft? This is where things get truly wild. The original warp drive model from the 1990s required an absurd amount of negative energy. Think the mass energy equivalent of an entire star. It was a non-starter, a mathematical curiosity with no hope of practical application. But in recent years, new research has flipped that assumption on its head. A physicist published a groundbreaking paper in 2021 that proposed a new approach, one that doesn't rely on exotic negative energy at all. Instead, it uses something called soliton waves, compact self-reinforcing packets of energy that hold their shape as they move. By arranging ordinary matter and energy in precise geometric configurations, it's possible to mimic the effects of a warp bubble without needing impossible resources. This isn't just a tweak to the original idea, it's a complete paradigm shift. Suddenly, the energy requirements are within the realm of possibility, not something we can do tomorrow, but something we might achieve with advanced fusion reactors or other technologies in the not-so-distant future. The barriers are crumbling, and the path to warp drive is looking less like a pipe dream and more like a roadmap. But here's the catch. Even if we can create a warp bubble, can we control it? Stability is the next big hurdle. A warp bubble isn't just a cool sci-fi gimmick. It's a distortion in the fabric of reality itself. If it collapses or expands uncontrollably, it could wreak havoc on space-time, tearing apart anything in its vicinity or creating unpredictable ripples across the cosmos. Scientists are grappling with this challenge, running simulations to test how these bubbles behave under different conditions. Some models suggest that with precise engineering, we could maintain a stable warp field, but others warn of catastrophic consequences if we get it wrong. This is uncharted territory, and every step forward is a leap into the unknown. Yet the fact that we're even asking these questions is a testament to how far we've come. Just a few decades ago, this was pure fantasy. Now it's a problem of engineering. Let's pause for a moment and consider what this means. If warp drive technology becomes real, it won't just change how we travel. It will change who we are. Imagine a future where humanity isn't confined to Earth or even our solar system. With a warp drive, a trip to Proxima Centauri, the closest star to our Sun at 4.2 light-years away, could take days or weeks instead of thousands of years. We could send explorers to distant exoplanets, scout for habitable worlds, and establish colonies across the galaxy. This isn't just about faster spaceships, it's about becoming a multiplanetary, multistellar species. Entire civilizations could rise around the ability to traverse star systems, reshaping our economy, our culture, our philosophy. The stars wouldn't just be points of light in the sky. They'd be destinations, as reachable as a neighboring continent once was to our ancestors. The implications are staggering, and they hit you right in the gut. This is the kind of future that makes your heart race, the kind that makes you wonder what it means to be human. But it gets even crazier. Warp drive isn't just about moving through space, it's about manipulating space-time, the very fabric that governs reality. Space-time isn't a passive backdrop. It's the stage where everything happens, from the orbit of planets to the ticking of clocks. It dictates how mass moves, how gravity pulls, how time flows. If we can bend space-time at will, we're not just building better engines, we're rewriting the rules of the universe. Think about it. If you can compress and expand space, what's stopping you from tweaking time? The equations that describe warp bubbles are eerily similar to those that describe wormholes, cosmic shortcuts that connect distant points in the universe. Could we stabilize a wormhole with negative energy, creating a tunnel to another star system or even another galaxy? And what about time itself? Einstein showed that time and space are intertwined, so manipulating one inevitably affects the other. Could we create regions where time slows down or speeds up, allowing astronauts to travel vast distances without aging? Could we even glimpse the past or future through some kind of temporal lens? These aren't just wild hypotheticals. They're showing up in serious scientific discussions. Some researchers believe that warp drive research could be the first step toward technologies that let us sculpt time as easily as we shape space. Imagine a spacecraft where time on board moves at a fraction of the rate outside, letting explorers return to Earth centuries later without aging a day. Or picture a device that accelerates time in a controlled environment, letting scientists run experiments that would normally take millennia. These ideas push the boundaries of what we think is possible, and they force us to confront questions we've never had to answer before. If we can control space-time, what are the ethical implications? What happens to causality, to the linear flow of history? Are we ready to wield this kind of power, or will it unravel the very fabric we're trying to manipulate? Stakes couldn't be higher, and the possibilities couldn't be more exhilarating. Now let's take it a step further, because this is where things get truly mind-melting. Warp drive research isn't just about building a faster spaceship. It might be the key to unlocking the deepest mysteries of the universe. Consider dark energy, the invisible force that's driving the cosmos apart at an accelerating rate. It makes up nearly 70% of the universe, yet we know almost nothing about it. But here's the kicker. Dark energy behaves a lot like negative energy, repelling rather than attracting, expanding space-time rather than contracting it. What if, in our quest to create warp bubbles, we stumble upon the secret of dark energy? What if we don't just build a warp drive, but decode the invisible architecture that holds the cosmos together? This isn't as far-fetched as it sounds. The mathematics of warp drives, particularly in newer models, hints at connections to quantum gravity, the long-sought unification of Einstein's smooth space-time with the chaotic, probabilistic world of quantum mechanics. For over a century, physicists have been chasing a unified field theory, a single framework that explains how all forces, gravity, electromagnetism, the strong and weak nuclear forces, fit together. It's the holy grail of physics, a dream that eluded even Einstein. But warp drive research might be the missing piece. The equations that describe warp bubbles are starting to bridge the gap between the macroscopic world of gravity and the microscopic world of quantum fields. They're revealing patterns that suggest space-time isn't just a passive stage, but an emergent property of deeper quantum processes. In other words, by studying how to bend space, we might uncover why space exists in the first place. By learning to manipulate time, we might discover what time really is. And if we push far enough, we might even start to ask whether consciousness itself is woven into the fabric of space-time, a byproduct of the same forces we're trying to harness. This is the point where the implications become almost too big to grasp. Warp drive technology, if realized, wouldn't just be a tool for exploration. It would be a window into the source code of reality. It would force us to rethink everything we know about the universe, from the Big Bang to the nature of existence itself. Are we on the verge of discovering a single, elegant equation that ties together energy, matter, space, time, and even the spark of awareness? Is the warp drive just the tip of the iceberg, a side effect of a much deeper truth? These questions aren't just philosophical, they're being debated in labs and conference halls right now. The research is moving fast, and the early signs are pointing to something profound. We're not just standing on the edge of a technological revolution, we're standing at the threshold of a new understanding of what it means to exist. Let's bring it back to Earth for a moment, because the human side of this story is just as compelling. Warp drive research isn't happening in a vacuum. It's being driven by brilliant minds who refuse to accept that the stars are out of reach. These scientists are the modern equivalent of the explorers who crossed oceans and scaled mountains, driven by a fire that's uniquely human. The need to know, to push, to dream. They're not just crunching numbers or running simulations. They're chasing a vision of a future where humanity isn't bound by the limits of our planet or our physics. And that vision is infectious. It's the kind of thing that makes you want to leap out of your chair and shout, "This is what we're capable of." It's a reminder that our species has always thrived by asking, "What if?" and then finding the answers, no matter how impossible the question seems. If warp drive becomes reality, it will be more than a technological triumph. It will be a philosophical one. It will prove that the universe is more malleable than we ever imagined, that reality itself can be shaped by our ingenuity. It will show that the stars aren't just destinations, but invitations, calling us to step beyond the cradle of Earth and into the vastness of the cosmos. And it will force us to confront the biggest question of all. What do we want to become? A species that huddles on a single planet, or one that scatters its light across the galaxy, carrying curiosity and wonder to every corner of the universe? The choice is ours, and the tools to make it real are closer than ever. But here's the most emotional part of all. This isn't just about the future. It's about who we are right now. Every breakthrough, every simulation, every late night in a lab is a testament to the human spirit. It's about the courage to chase the impossible, the resilience to keep going when the odds seem stacked against you, the audacity to believe that we can touch the stars. Warp drive isn't just a machine. It's a metaphor for what makes us human. It's the spark that drove us out of caves across continents to the moon, and now maybe to the edge of the galaxy. It's the voice in our hearts that says, "There's more out there, and we're going to find it." And when we do, we won't just be exploring new worlds, we'll be discovering who we've been all along. So where do we go from here? The road to warp drive is still long, filled with challenges and unknowns. We need to refine the models, scale up the experiments, and solve the problem of stability. We need to figure out how to generate the energy required without bankrupting the planet or breaking the laws of physics. And we need to ask the hard questions about what it means to wield this kind of power. But the signs are clear. We're closer than we've ever been. The equations are getting sharper, the simulations more precise, the labs more ambitious. What was once a footnote in a physics journal is now a priority for research teams around the world. And if even a fraction of this work pays off, we could see the first proof of concept, a tiny warp ripple, a controlled distortion of space-time within our lifetimes. It won't be a starship ready to cruise to Alpha Centauri, but it will be a signal that the barrier is breaking, that the impossible is becoming possible. This is the moment to feel alive, to feel the weight of what's at stake. Warp drive isn't just about bending space, it's about bending the arc of human history. It's about taking the dreams of our ancestors and turning them into reality. It's about proving that the universe isn't a prison but a playground, waiting for us to explore, to create, to thrive. So ask yourself, what kind of future do you want to live in? One where we stay tethered to the ground, or one where we soar among the stars? The answer is up to us, and the tools to make it happen are already in our hands. This is our chance to redefine what's possible, to rewrite the story of humanity, to become not just observers of the cosmos, but architects of its future. The warp drive is coming, and with it, a new chapter in the greatest adventure of all time. Are you ready to be part of it?